Hi, this is John Smiley. I'm an Amazon solutions architect. I'm here today to present to you some information about RDS MySQL. We're talking about best practices for RDS MySQL and data migration. Just real quickly go over the list of things we're going to cover today. So we're going to do a quick intro to RDS for those of you who haven't had RDS before, and those of you who had, this won't take very long. We'll just hit the high points. And then we'll spend some time talking about how to migrate your databases into and out of RDS. We'll spend some time also talking about availability and disaster recovery best practices. And then after we finish that, we'll do a live demo for you to show you how to do the actual steps for getting into and out of databases, RDS MySQL databases. And then we'll take your questions. So Amazon RDS is a managed database, SQL, relational database in the cloud. It's an SQL type of database. And one of the main advantages to RDS is that it's very fast and simple to deploy. You can use a command line or an API, or most people use a console available to create and modify and manage their RDS instances. We handle tasks that are kind of the drudge work of databases for you, repetitive tasks such as doing backups and setting systems up, doing provisioning, and giving you the ability to do scaling with storage instances. So if you want to add CPU, you want to add memory, you can scale storage and memory, CPU and memory easily. You can also scale storage. You can add gigs, and you can change the performance in terms of IOPS and throughput up or down. We strive to make all of our applications or all of our engines are compatible with your applications. So we have four RDS services today. That's MySQL, PostgreSQL, SQL Server, and Oracle. And we recently announced Amazon Aurora, and I'll talk about that for just a few minutes towards the end. The systems are designed to be secure. We have SSL encryption over the wire and at-rest encryption for each of the databases today. And if you do some cost comparisons in terms of the licensing and infrastructure costs, you'll find that we're very competitive and cost effective. As I mentioned, Amazon RDS is simple and fast to deploy. You can go. This is a picture here of the console showing a MySQL database being created. And you just specify the instance class. Here you see it M34X large, which specifies a certain amount of memory and CPU. Whether or not you want to make this a multi-AZ deployment, and I'll talk about multi-AZ later on in the presentation, and what type of storage and how much storage you want to have, and depending upon the type of storage you select, what the performance characteristics are going to be. So it just takes a couple of minutes to get this going. You fill in this little bit of form here, and click the instance to start, and just a couple minutes later, your database is provisioned and up and ready to go. So there's no need for you to have to go out and buy hardware, install software. We do all that for you, and then we also handle things like backups. You can specify how long you want to retain the backup information. The default is 7 days, but you can change that. And also there's a maintenance window, so if we need to do patch management for the operating system or for the database binaries, it just specifies that there's a time where the system can be taken offline briefly to do patch management, and you have full control over when that's going to take place. As I mentioned before, we have backups that are implemented for you, and one of the things that you can do that normally would take a DBA or an administrator a fair amount of time to get set up and working is point-in-time restores or point-in-time recoveries, as this is showing. It allows you to return the database to its prior state to you specify a point in time in the past within the backup retention window, and brings the database back up as a separate database that you can then do your recovery from. So there's a number of things that have been transpiring in the past year or so. I just want to mention some of the highlights of some of the things that have changed recently. We've added an encryption at rest, transparent encryption at rest for all the database engines. We've also got general purpose storage, which is a new type of storage that we introduced. In addition to magnetic and PIOPS, this general purpose storage is SSD backed, very much like PIOPS is, and it falls between magnetic, and PIOPS in terms of cost and performance. We've also added a number of new instance types. There are kind of mid-range instance classes, high memory instance classes, and some smaller instance classes that we've introduced to kind of cover some more use cases. We also introduced cross-region replication for MySQL, and as well as being able to create, to upgrade the database from 5.1 to 5.5 and from 5.5 to 5.6. Note that you do have to go through that step. If you're on 5.1 and you want to go through to 5.6, you do have to go through the 5.5 as a separate step. But it is all automated. It doesn't take very long. You can have the upgrade done in just a few minutes. MySQL also introduced the InnoDB cache warming that allows you to tell MySQL to remember what was in the InnoDB buffer cache when it shuts down, and then bring that information back into memory when the database starts back up again. And we give you control over that, and you can make use of that very nice new feature, and we'll show you what the impact of that is shortly. So just wanted to show you some of the customers that are using RDS today. This is just a very small number, but some names here you might recognize to you with that. So let's talk about data migration. So one of the first things that people want to do when they set up a new database in RDS is they want to migrate their data from wherever they're storing it now to RDS. And in some cases, it's necessary to migrate back out again. So we'll cover both. We'll start with importing from an external MySQL source. So if you've got a database that's running MySQL outside of RDS, you've probably got an application sitting on top of that, and there's a master database underneath it that it's talking to. You've got your backups that are being taken and stored, hopefully offsite somewhere. And then if you've got a slave, you're probably taking your backups from the slave to avoid impacting the performance of your master. And then if you want to start moving this into RDS, we start with creating a staging server. This is an EC2 instance in the same region where your on-premise is going to be. And you would copy your backups over to the staging server using a utility like SCP. There's a variety of different ways you could get that working, but SCP is a common utility to do that. And then setting up an RDS database, and it's going to be acting in this case as a slave database, the S there. And we'll be loading the data from the staging area into RDS, and then we start replication between your master and the RDS slave. And in this way, we get the data into and caught up with the main application in your external MySQL database. Now, when it's time to start using this, the RDS database as a primary, you get your applications up and running and point to either inside of AWS, or you can just point your applications that exist today to your RDS instance. You would promote that instance to a master, get your applications talking to it, and then you've got a failover or a migration. This is the migration in. If you're coming from an external source, there's a few things to take into consideration. You'll most likely want to take a backup from your replica or a slave, so you're not impacting your master. Since we're going to be taking those maybe across the internet in a lot of cases, we'll want to compress them so that they will transfer faster. And as I mentioned earlier, moving these to a staging server in EC2. The advantage for doing this is to get the data across the internet into AWS so that the data is localized in terms of its network connectivity to RDS. So you're already in AWS, you're on the same network, you've got a much higher bandwidth, low latency path, so that if something were to occur and you have to go back and redo something during the import, it's easier to do that. You don't have to retransfer the data. If you can insert the data as a primary key order, that helps during the insert or the migration in portion, so that as the data is being loaded, the B trees can be if they're loaded in primary key order, the data is more compacted, the migration will go faster. So now we're going to talk about using RDS as a target for migration. This is again kind of continuing on what we're talking about with if you want to add more memory, you want to add IOPS, this will make the loading go faster. So you can specify an EC2 instance class on the RDS side with as much memory and CPU as you need and storage IOPS to handle the import load. Now, it's sometimes advantageous to just to provision more an instance class that has more memory and more IOPS that you might be using during production, so the load goes faster, and then you can change those later on after the migration. You got your database in. It's not necessary to keep the extra memory in the IOPS. It's just an option for you, so you can save some time and money. So the RDS configuration is to avoid having the extra overhead of multi-AZ during the import. We recommend that you disable multi-AZ if it's already enabled, and also to disable backups by setting the backup retention to 0. And that just avoids doing a lot of the extra overhead while you're loading a bunch of data in. You can always turn these things back on. Certainly would want to turn these things back on later. On the MySQL side, there are some parameters you can set that will also speed things along a little bit. And that's to set the InnoDB flush log at transaction commit to 0. This is an InnoDB flag. Setting the MySQL auto commit to 0, and also turning off checks for uniqueness on foreign keys by setting that to 0. And then if you're or if you're using RDS MySQL 5.6, you can also increase the InnoDB log file size. The default is 128 meg, and it can be advantageous to increase that just to reduce checkpointing during the import. So the input format is generally one of two types. For the input files, you can either input SQL or you can input flat files. So the MySQL dump utility can be used to create either type of output file. The standard for MySQL dump is to use SQL, and you can also tell it to use fields terminated by and optionally enclosed by to create a CSV, kind of a separated values file. So the same utility can be used in both cases. The advantage to using the SQL format is that it will load the schema and the data at the same time, and it also will automatically turn off the index constraints that we were talking about just on the previous slide. On the flat files, if you have a lot of data to load, this might be the better way to go because, as we're going to see here, the execution for just loading things in directly with SQL is sequential. So if you have a lot of data, that could take a while. And it may be advantageous to create the flat files, split them up into a large number of small files, load them in parallel, and that way you can get the data into the database a lot quicker. If you need to restart after failures, if you need to restart, you can easily restart after failures with the SQL approach. And if you're using flat files, you can also do resuming using the checkpointing capabilities of the database. And as I mentioned, there's the SQL approach, since it's going to be sequential, is probably best for smaller databases of a few gig, and flat files loaded in parallel would be a better approach for larger databases. So this is how to configure the RDS database as a external replication source. So you'd go to your on-site or your on-prem MySQL database. Use the MySQL dump utility to create the data file, the output data file for, in this case, it would be called sample dump.sql. Specifying the database that you're going to be exporting, or you can specify multiple databases. And the master data equals 2 basically tells MySQL dump to write to the file the master bin log position. So you can create the output file using this method. It automatically does all the things like turning off the foreign key checks. It does a consistent read using the single transaction flag, and it also creates writes the bin log position into the output file for you, so you can pick that up later on. On the master, you would need to create a replication user. You probably already have one. If you're using replication already, it's probably a good idea to create another replication user for this purpose, just to migrate into RDS, so you can kind of manage and maintain those differently. Of course, you could use the same if you chose to. It's just it's up to you. But you can create a new replication user if you're going to do that on the current master, and this is what you'd be using on the RDS side to tell it how to connect to your database. So now overall to the RDS MySQL database. This is where we take the information about the master bin log position and the account that you're going to be using, and we tell RDS how to connect to your external database. So we give it the name of the database and the replication user credentials, the port number, and then the master bin log position, which is shown here. And the reason we do it using this call MySQL RDS set external master, that is a stored procedure that RDS provides for you to do essentially what is a change master call. RDS, the change master command requires a super privilege, which the RDS admin account doesn't have. So any of the operations that need to be performed using the elevated privileges can be done by proxy using the provided RDS stored procedures. So you would, at this point, stop the app pointing at the current source and stop replication. So you would use the MySQL RDS stop replication call to tell RDS to suspend replication. And this allows you to take a backup of your database separately without having to worry about applying bin logs. Just pauses replication to do that. And then you would promote the RDS external master instance once you've got everything ready to go. And that tells the database to begin operation as an external master, to expect to receive bin logs from an external source. Oops, sorry. Let's see. Okay, so now if we're going in the other direction, we're exporting data to an external source. We've got our data in RDS, and we want to move it to someplace outside of RDS. We have our application running, talking to our RDS MySQL master. We would do sort of the same thing in reverse. We would dump the data out and to a staging server within EC2, and then copy the data over to your master, and basically set up the new master as a slave from RDS. And when we get to the live demo, I'll be demonstrating exactly how to do that. And you can see here, this is showing the replication taking place between the external and the internal. You would set, again, with using an RDS specific store procedure, the RDS set configuration, to tell the database server to retain the bin logs. This will be if you're coming directly from the master. There's other ways to do this, and this is what I'll show you that in the live demo as well, so that you're taking it from a slave and not from the master. But if you wanted to take it from the master, this tells the master to retain the bin logs so it doesn't purge them off as you're trying to migrate your data. Now we're going to move on to the topics of availability and disaster recovery. So high availability in RDS is implemented as a feature we call multi-AZ. This is where we have a region in the EC2 that has multiple availability zones. You're running your application and your primary database in one AZ. And then in the second AZ, you're running a copy. It's a physical synchronous copy of your database. And this is something that we do for you. It's an option that you can turn on for your databases. We take care of all the setting up and maintaining of the replicas. So multi-AZ deployments are physically synchronous. We're taking each write that goes to the database has to be acknowledged by both the primary and secondary before it's acknowledged back to the application. And you can have the application up and running. I recommend that you do this so that it's all provisioned and ready to go, and just pointing at the primary and the other AZ, so that you can either run both sides live or just one side hot, one side cold. If the primary goes down, then we have an automated process that will detect a failure. Can take it up to 25 seconds to do the failure detection, and this has to do with timeouts for leases and understanding when the heartbeats for the system have stopped arriving. That's how it does the failure detection, and then we will promote the standby to the primary, and then we'll change the CNAME. We'll take the CNAME that was being used by the endpoint for your database that was in AZ1 and repoint it to the one that's now become the primary in AZ2. And we do that using a CNAME update in DNS. It takes about 30 seconds for that CNAME to propagate for your applications to pick that up. So total failover time between detection and having your database back up and ready to go again, about 1 minute. And then once the problem has been healed, the old database that failed is brought back up again, and it resumes service as the secondary. Read replicas are another way to get high availability and high durability. Notice that again, this is showing the difference between multi-AZ, which is using synchronous replication, and the asynchronous replication that's used by read replicas. So MySQL read replicas use binlog replication, native binlog replication that you're all familiar with if you've used replicas with MySQL in the past. And you can specify where, you can specify different types of instance classes. They don't have to be the same as in the multi-AZ, where the instance classes are always the same so that you have the same capacity available to you after you failed over, as you want to have a failover to an instance that has less capacity. So we manage that for you. And then, so read replicas are a little different in that the replication is asynchronous. The reads are going to be eventually consistent as opposed to on the primary where they're strictly consistent. That's because MySQL has a little bit of replication lag. It doesn't necessarily have to be caught up all the time. And you can see, and I'll show you again during the live demo, but you can see where how much replication lag there is by using the show slave status. And then you can have multiple read replicas. You can have up to 5 MySQL read replicas. If you need more than that, just let us know, and we can change the quota if you want to go higher than 5. If the primary goes down, in this case, you can use one of the read replicas as your primary. This is showing the multi-AZ, how things work with multi-AZ and read replicas, where you've got a failover from the secondary to the primary. And this is similar to what we saw on the previous slides, where the new primary has come up, and it automatically pulls over the information that it needs to become the master for the read replicas that you had before. So there's nothing for you to do. We take care of all this for you in making sure that after we've moved the primary from one place to another, after multi-AZ failover, that the read replicas follow the primary. So then you'd repoint your application to point to the new primary as before, and your reads would continue, your read applications would continue as before, no changes. Now, if the read replicas were to go down in 5.1 and 5.5, it's possible that the slave and the master can get out of sync, and this is something that you may have run into before, where the master starts a new bin log, and the slave doesn't know about it. And this is the typical setting for MySQL 5.5 and before, is to have sync bin log set to 0. And so when the master crash recovery completes, it starts a new bin log, but the slave doesn't know about that. It still thinks it's still looking for the position from the older bin log. So you get this divergence between the master and slave, and sometimes it's easy to fix, and sometimes it's required, it's necessary to restart and rebuild the replica. Fortunately, it's very easy to do in RDS. It's just an API call, go to the console. So you want to create a new slave, and within a few minutes, the slave will be available to you. But there is, some period of time where that slave is not available that for your read applications, and so it's maybe necessary to turn on bin logging or sync bin logging. And in 5.5 and 5.1, this causes a performance hit for 2 to 4 times a performance hit on your applications. Now in 5.6, Oracle's done some work on this, and they've made sync bin log set to 1 the default. And that allows and they've also added some other nice features too to kind of make replication more reliable and faster. So bin log commit is a great new feature so that it doesn't have to make multiple trips to the bin log, and it can batch up the commits and write them all at once. And this allows us to do crash save slaves so that there's less downtime for the read replicas. They're much easier to come back, and there's no performance hit. As you can see here, we've done some testing with the sync set to 0 and 1, and there's very little difference between the two on 5.6. And even with it turned off MySQL 5.5 in terms of the throughput and transactions per second, you can see the significant improvements that have been occurring since 5.5. So it's okay to turn sync bin log on. That's what we do now by default if you specify an RDS MySQL 5.6 instance. And that way, if the master does crash and has to come back up, the master and the slave will most likely be in sync, and there's no need to restart or recreate the replica slave. So how do you do disaster recovery using read replicas? Well, one way would be to set up a read replica in another region. So we're going to talk briefly here about starting with a database and an application running in one AZ in one region. We're going to do the multi-AZ synchronous replica. And then to make it possible to fail over to another region. We're going to create a read replica. In the console, you can specify a different region when you're creating a read replica. And this allows you to do asynchronous replication with MySQL 5.6 to another region. Application's up and running. Everything's talking to the primary until something happens to the primary. And let's say the entire region goes down, and you want to be able to continue to be up and running. Then you can then use your read replica in the other region to take traffic and remain up. So scaling and performance. There's the main point to take away from this, as you'll see, is the read to write ratio is a critical factor in how well you're going to be able to scale. So if you've got a 90-10 read-write ratio, you can get 1x scaling pretty easily. You take those reads and stripe them or move them across multiple read replicas. We got 4 here. And notice that the writes all have to occur everywhere. So a write on the primary is the same write has to take place on all the replicas. And so we're taking that and we want to go to double that for 2x scale. We're doubling the reads and writes. And notice that the capacity of the primary is still plenty of extra capacity. The read replicas are now taking on more of the load because they're having to do all of the writes that are occurring on the primary, and also having to handle the extra read load. And I can do that one more time before I start running out of capacity at the 90-10 ratio. Now, if we start to use more writes, if we're using an 80-20 ratio, the scaling gets to be a little bit of a different story. So once again, I've got 4 replicas, again having to duplicate the writes that take place on the primary to each of the replicas, and then taking that read workload and spreading it out across the 4 replicas. And I can do that one more time at the 80-20 ratio before I'm kind of out of capacity. So you can see that based on the read-write ratio, the scaling that you're going to get is highly dependent on that. And it just is the nature of having to duplicate the writes from the master onto all the replicas. So if you have a read-to-write ratio of 50-50, you're going to get significantly less scalability than you would if you had a 90-10, and you can see there's some branches in between. So as I mentioned earlier, there's a new feature with InnoDB called cache warming. This allows you to save the state of the buffer pool, and you can then bring the database back up. And normally, before this feature was available, the cache would be cold and it would have to be going to disk to start warming the cache back up, and you'd have some performance hits. And we've shown that using this feature, you can get about a 4x improvement on throughput. Just by dumping the buffer pool and then reloading it after the database is started back up again. And in this example, you can see there's about a 9-minute period of time where it takes about 9 minutes without the cache warming for things to get back to a warm state and performance to resume its previous level. And that for a good portion of those 9 minutes, you're getting about 4 times the performance with cache warming turned on. You can enable cache warming with InnoDB from our parameter groups within Amazon's RDS. The DB parameter groups are the area where we go to manage all the settings for your database. And in this case, there's 2 of them. For one of them to set to dump the buffer pool at shutdown, and another one to load it at startup. So for unplanned failures, it's probably a good idea to set up a job within MySQL to dump the cache or dump the metadata about the cache on a periodic basis. Otherwise, if it's only being dumped at a normal shutdown, the information that was in the cache at the time during an unplanned failure may be out of date. And so to keep it up to date, just set up a periodic dumping of that buffer cache metadata. And that way it'll be no more than some number of minutes or hours out of date. It'll be much closer to the optimal value when it comes back up. Another thing to take into consideration is how to manage schema change. So there's 3 major areas to think about when considering schema change, and that's ease of use. You know, how difficult is it to perform schema changes? How well does the system perform while we're making the changes, and how long does it take to complete? So we got several options for doing this. We can use read replicas to create schema changes on the replica and then promote the replica once we're done. We can use the native 5.6 functionality. In 5.6, they've added some nice new features to do DDL online. They continue to improve on this, and you can do certain operations online with MySQL with no downtime, although there is a performance penalty, as we'll see shortly. You can also use third-party tools like the one from Percona, and I'll show you a little bit about that. This kind of falls somewhere in between these two in terms of performance and ease of use, as we'll see. So if we use the read replica approach, we'll start off with a primary, and we're using a read-only replica. Now, before we can make any schema changes, we need to change the parameter to make it read-writable. There's a read-only parameter on the replica that you would change to make the replica read-writable. Then you can make your schema changes. In this case, we're just adding a column to a table. And then we would want to create a second replica. So this will be a replica of the replica to take so that when we flip the primary over to the replica with the changes, you've got your replicas already built, and you can do the same thing with multi-AZ if you choose. So now we've promoted the replica that we made the schema changes on to the master, and it's replicating to its replica, and you're back to the same state that you were before doing the promotion. And this is with the schema changes. Then another way is to use the MySQL 5.6 built-in features. The nice thing about this is it's really easy to use. They're just standard DDL commands for MySQL. And the downside is there is a performance impact. So if it's going to have to reorganize the data in some cases, that could impact performance in terms of how much memory and CPU and disk I/O is taking place. It's going to be using the system resources as fast as they can. You don't have any ability to control or throttle how much I/O or CPU is being used, so it's just going to consume as much as it can and get done as fast as it can. So this can lead to increased replica lag depending upon the types of changes that you're doing. When the resources become constrained, sometimes the replica is not able to keep up, so just keep that in mind. And then the time to complete is relatively less than if you were doing it in other ways that we just talked about, one of them being using the read replica. So then the third way is to use the Percona tools. This is the pt-online-schema-change. This is in their Percona toolkit. It's a Perl module, so you'll have to install Perl to get this to work. But here's an example of using this their schema change utility to make changes to schema on a system without using either replicas or the native 5.6 features. And why would I want to do that? Well, it does require me to install some extra software on my side, but there's less of a performance impact. So it allows you to throttle the amount of system resources that are being used during the schema change, so that you can minimize the impact on the master while this is taking place. As a result, this can take a little bit longer than doing it in other ways. And we've done some side-by-side comparisons here for you to kind of illustrate how this works. So as you can see, the Percona method is performing better than the native MySQL method, but the native MySQL method finishes earlier than the Percona. So Percona is going to take longer. It's just going to spread that performance impact out over a longer period of time. So it's up to you which one is the better choice for you. So if you're just looking at the three different ways of doing replica schema changes and comparing them to the three areas of consideration we talked about, the easiest to use is the native MySQL 5.6 online schema changes, and then read replicas. Read replicas would be probably the least easy to use, with Percona being somewhere in the middle. However, read replicas, although they're not as easy to use, perform the best of the three. And as we saw from earlier, the performance impact from doing it with native MySQL can be significant. And then with Percona tools, again, it's sort of in the middle. It gives you a nice choice between the two ends of the spectrum. And then the amount of time taken, read replicas perform the best. They also take less time overall. But if you need to use the native MySQL replication, that can take a little more time than using read replicas, but probably a little less time than using Percona, as we've seen. Some other best practices I'll mention: the storage engine Always be InnoDB, especially avoiding engines that don't have transactional capabilities such as MyISAM. And the reason for that is if there's an engine crash, database crashes, you want to have a transactional engine that can recover and not lose your data. MySAM and other non-transactional engines don't have that capability, so it's possible to have data loss. So we recommend using InnoDB for everything. We offer a number of different metrics that you can alarm on. So you can go into CloudWatch. We're publishing metrics such as CPU and memory and storage, I/O latency, replica lag, I/O throughput. All these things that you can see them from the console within the RDS console under the monitoring. And then, so all those metrics are published to CloudWatch, and you can go into CloudWatch and set alarms on them. You can use the simple messaging service, which is an email notification service, another AWS service, to watch to capture the alarms, and when the alarms are triggered, to notify through email what the event is, so you can take action on those. Another thing that we've noticed that is in some cases, customers have many tables, many thousands of tables, and this can cause the database to take quite a while to recover after a crash. MySQL will use a single threaded process to go through and check each of the data files. And if you have tens of thousands, hundreds of thousands, I've even seen millions, it can take quite a while to go through and check each one individually. So if you can, try to keep the table count down, keep it under 1,000 to if you're using standard storage, or under 10,000 if you're using some of the faster storages like PIOPS and GP2, just to keep the crash recovery time down. And as you maybe have seen already, we announced Amazon's new database engine. This is a MySQL compatible relational database engine called Aurora. It's built on top of a number of AWS services, and it's a relational database engine that takes advantage of many of the cloud services that we provide to provide you with a database server that will scale farther than current MySQL offerings and give you better performance. We've done a bunch of re-architecting of the storage layer. We've moved the logging and storage layer out of the database instance itself and down into its separate storage service. This allows us to do scale out much more easily and allows us to make the data highly durable and available without having to impact the primary database. It allows us to do things like keeping the cache warm across a database crash. So if we were talking about cache warming earlier with the MySQL new MySQL service or feature that allows you to just dump out and reload the cache. In Aurora, that's not necessary. We actually keep the cache warm in a separate area. So the instance goes down, the database cache is gone, but the storage layer keeps its own separate cache. So when you're starting back up again, it's much faster to get the cache rewarmed. And we're using Amazon S3 as our backing store for backups. As you may be aware, Amazon S3 is designed for 11 nines of durability, so it's a very safe place to put your data. And for our control plane, we're using the scalable NoSQL database service called DynamoDB. It's also a highly redundant, durable data store. And so if one of the storage engines were to go out or we lose an entire region, DynamoDB is capable of keeping us up and running, even in the face of an entire AZ going out. We use Simple Workflow as another one of the services that customers are available to customers. We use this internally to specify how the control plane is going to, what actions it needs to take, and for each of the different types of API calls. And then Amazon Route 53 is our DNS service that we use for managing the endpoints and notifying the clients as to how to access the database or where the database is on the network. So similar to the other RDS offerings, Aurora makes it easy to create databases very quickly. It just takes a couple of minutes to get one up and running. Because the storage layer has been re-architected, we can offer some new features such as instant on-volume snapshots. If you've used EBS snapshots or you've used RDS and done snapshots in the past, you may have encountered some performance impact while snapshots are being taken. The new storage engine in Aurora is architected in a way that prevents that. You can take a snapshot, it's done instantly, and there's no performance impact to the database. We're continuously taking backups of the database all the time, and taking those backups and moving them to our S3 backing store so that they're highly durable. We also allow a much larger database size than is currently available in RDS today. So the maximum database size for Aurora is 64 terabytes. For the other database engines today, it's for MySQL, SQL Server, and Oracle, it's 3 terabytes, and for SQL Server, it's 1 terabyte. So quite a bit more room to grow with Aurora. And it automatically does restriping. If it finds a checksum error, for example, it will automatically repair mirrors. If it notices that you're getting hotspots and you're accessing the same area of storage frequently, it'll start spreading those things out and do some heap management. And it also encrypts the data for you. So to conclude, I just want to make sure that if you don't if you take away from these points, then if you take nothing else away, these are the things you should remember from this session. Let RDS manage the databases for you. That's the main focus for RDS, is to make the drudge work of managing databases easier, so you can spend your time focusing on your business and not the database. There's as we're going to see shortly in the live migration or the live demo, that you can migrate in and out with low downtime solutions. There's just a couple of minutes in migrating in or out. You can use multi-AZ for high availability. So if we lose a data center, we lose an AZ, your database can remain up, your application is still up and running, talking to a copy of the database with no data loss. For read scaling, you can use read replicas, and you can have, again, up to 5 of those. And if you need more, we can make that available to you. For disaster recovery purposes, we talked about using cross-region replicas, and we went through briefly how that works. So if for some reason an entire region were to go out, it's possible to keep your application up running in a separate region. And then for managing schema change, we went through several different methods for doing that and talked about the pros and cons of each. Here is, I have set up some RDS databases and some EC2 instances to kind of show you. I'm going to quickly just show you what we have for the RDS side. So if we're going to be using RDS as the source database, and we're moving out of RDS into an external MySQL database, I've got my RDS source and my RDS source read replica one. So I'm using the master and the read replica. Replica is going to be the place where I'm going to be taking my backup to make a copy over, and that way my source, my master database, can continue taking workload. There's no interruption to service. If I'm moving into RDS from an external source, I'm going to be moving it into this database I've named my RDS slave, and then after, of course, you move it into your applications have been moved over, switch over, you would promote this one. Notice that on the MySQL RDS slave that I don't have multi-AZ turned on, and I don't have backups turned on, as we were talking about earlier in the slides. So this is something that we would only want to do while we're doing the load. Once this is done, obviously we would turn these things on to protect the database and keep the data secure and available. The read replica is set up as you would with any read replica. It's just the same. As you can see, it's the same class of instance, has the same capacity as the primary. So here I'm over here on one of the EC2 instances, where I've got a similar setup on the EC2 side, where I've got my source database with a master and a slave for migrating into RDS, and then I've got another database, another instance where we can show migrating out of RDS. So I'm going to start off by we're going to start off with migrating to RDS from an external. So we're going to be coming into RDS. I've just made some notations here about the different instances. These are the EC2 instances that host my current databases, and then a note here about the target RDS instance. And keep in mind that you'll probably need to configure the RDS security groups and EC2 security groups to allow communication between the databases while you're doing this, and you can always change that after you're done. But the next thing to talk about is the source slave. So I'm going to be using on my EC2 side, I've got a master and a slave. I'm going to be using the slave as a source. So I'm going to go ahead and connect it. And you can see that the slave is running and that there's no lag. So if you're looking for, if you wanting to know where to find replica lag, this is one place to find it. And if we have time, I'll show you there's a graph that we can see to do that. So I'm going to stop the slave. And the reason I'm going to stop the slave is because I don't want any more writes coming in. And that way I can now take a backup of the slave without worrying about changes taking place to the data while I'm trying to make the backup. And this also has the side effect of keeping the bin logs on the master, so that we're going to need those later on as we start to ship things over to RDS. And so you can see here, slave is stopped, and I want to get the bin log position. So I'm going to make a note here of the bin log position. Here it is. This is the bin log position we're going to be telling the new slave in RDS to point to. I'm just going to copy that right here. And we'll use that later on. Notice that the bin log file is number 2 and the bin log position is 2281. So before I forget, I'm going to go over here right now and take care of that. So let's do this. Easier to see. So 2281. Back here. All right, so later on we're going to be using that to set up the master. So the next step, now that we've recorded what the bin log position is, the next step is to actually migrate the data over. And this is not a lot of data. I know we didn't have a lot of time for this, so I made this fairly small. I'm going the easy route here using the SQL-based MySQL dump. And I'm also doing some things that are not best practice for the sake of time and convenience. I'm passing the passwords around on the command line. Obviously, you wouldn't want to do that in real practice. But I'll just take a minute and I'll go back over here and get ready for the next stage. So the next thing we want to do is configure our RDS instance as a slave to our external master. So I'm going to go ahead and connect to it. So now we're on, and I'll show you that this is some cleanup that I needed to do from the last test that I did. Okay, so now you'll see that there's no database here called SB test. And if I go back over to my source database, there's SB test. This is a sysbench in case anybody's curious about what that is. And I used 100 tables. Each of these tables has 10,000 rows in them. So it's not a lot of data, but it's okay for a demonstration. And you'll notice that the migration of the data has already, you know what? I think I messed that up because I was already copying the data over. So pardon me while I fix that. Let's take a second. Okay, so our data's coming over. So remember that I've already updated this to point to the current master bin log position on my external master. And we're going to use the built-in RDS procedure to do the change master to command. And then once this is finished, we can go ahead and start replication. Okay, the data has been copied over. And if you want to, we can take a quick look here and see. There's my 100 tables, each of which has 10,000 rows. Now I'm going to use the store procedure to turn replication on, and I'm going to show slave status so I can see that it has been turned on. So you'll notice that it's now pointing to my external master. Here's the external master we're talking to. And this is the bin log position that we told it to start with. The slave, IO, and SQL processes are running, so replication is now up and running. So now if I were to go to my external master, and make a change, let's say I wanted to create a new database. And I want to create a new table. So now this is the change that I made on the master, and I want to go back over to the RDS slave and show that that happened. And as usual, with live demos, it doesn't matter how much you practice, there's always something that goes wrong during them. So let's see. Oh, I know what I did wrong. This is the slave. Wrong place to make the change. So let's go back over here to the master. What's going on? Thank you. Must have had a typo in there somewhere. Okay, so we're on the master, and we're going to create the database. And if we go back over to our RDS instance, there's the new database. You can tell I'm a Unix guy. And there's my table. And there's the data in it. So replication is working between my external master and my RDS slave, and so now I can continue to make changes. As long as you're retaining the bin logs on your external master, the RDS slave will be able to pull those changes across and apply them. And at your convenience, you can make a change to point your application to RDS and promote that RDS slave to your main database, your master, and begin using RDS as your database. So now let's go the other way. We want to migrate, and this is probably is at least equally interesting as coming into RDS, is how do I get back out if I want to? So again, we have the RDS master and an RDS slave. We're going to be taking the backup that we're going to be instantiating our external target from the RDS slave. And I've got a MySQL database that's up and running on EC2. This could be on your on-premise, but EC2 is just a convenient place for us to do the demo. And so now I'm going to connect to my new external master. Because of the way RDS handles some administrative tasks internally, we're going to need to create a table to prevent replication from breaking. And it's just one of the internal tables. It's a heartbeat table that RDS uses. Those heartbeats get replicated out. And if we don't create this table, if it doesn't exist, replication is going to break. So I'm going to go ahead and create that table so that that doesn't happen. I'll show you that that this is just a straight vanilla install. There's nothing extra in here. And you can get this by showing a create table, say from the RDS instance. And this is what I did to create this. So now I've got my table created for the heartbeat, so the replication won't break. And I'm gonna now go over to my RDS master. And then there's the SB test database that I want to copy over. And I'm going to create a separate replication slave user for this purpose. So I'll need to do that on the RDS master. I know we're running a little over, but I'm almost done here. And then we're going to verify that that account got replicated over to the RDS slave, since that's where we're going to be taking our data from. This is just to verify that all the changes that we made on the primary have been replicated over to our slaves, and so we want our data source to be as current as possible. So there it is, we're on the slave, and that account that we just created has now been applied and created on the slave. And now we're going to stop replication on the RDS slave. And this does a couple things. One of it, stopping replication now says, okay, no more writes are going to take place on this slave. So I can take backups without having to worry about changes being introduced, and the backups being inconsistent. Yes, there are ways to make that allow changes to occur while I'm taking the backup, but we're taking the simple approach here for the demo. And then I want to make sure that the replication actually got turned off. So I'm going to do the show slave status. And we can see here that it did get turned off. And I'm also going to make a note of the bin log position because we're going to need that later on. And also notice that after I've turned off replication on this slave, that signals RDS to retain the bin logs on the master. So that way, when we start doing replication between the RDS master and your database, the external database, the bin logs will be available for it. And now we're going to run a similar MySQL dump, only in this case, we're going to go in the other direction. And I'll just take a quick second here to show you. I mean, this is using single transaction, which would allow you for writes to continue being made on the database, even though I've kind of done a belt and suspenders approach here and turned them off externally. And we're going to be getting the routines and the triggers, and we're going to get the SB test database. We're going to compress it, compact it, and then we're going to ship it across the network over to our external database. So once again, this is something that you wouldn't do in practice, passing the passwords on the command line. This will just take a second. I'll mention that one of the things you want to be careful about is not migrating or trying to merge the MySQL schema contents. The RDS keeps a number of things in the MySQL schema that you might not want when you're pulling them across to your database, and vice versa. So the best way to go is to migrate the data and then handle the accounts and the permissions separately, so that you're not trying to. You could do it. It's certainly possible to do the merge, but it just makes life a little easier to keep those separate. All right. I know we're running like almost done. So here's my binlog position. All right, so it's file number 247 and position number 714. So I'm going to go down here and make that change. And by now, my data copy has completed. So now I've just gone to the RDS database and told it to use the I've gone to my external database and told it to use RDS as my source for replication. It's going to use the new replication user that I created earlier. And now I'm going to start replication on my external database. Okay, and we can see that it's up and running. I've got replication started between RDS and my external, so I'm going out of RDS again into my external master. Now I'm going to make a change on the RDS database. So I've created a new database called ABC123 and a new table, as we saw, similar to what we did a little earlier going the other way. Now I'm going to go to my external instance and see that actually arrived. So those changes did propagate over just fine. So now we have replication up and running between RDS, going out of RDS into an external database. And so that is a quick and dirty way to, if you're moving small amounts of data around, you can do it exactly like this and it'll work just fine. If you're going to be doing it with larger amounts of data, obviously you're going to add some steps. If you're doing it in VPC, there's also some additional steps, but for time purposes, I just kept it short and simple. So that's it for the demo.